So now let's take a look at example number 9, the last example in this section. We've been looking at the fundamental theorem of calculus part 2 and how it's being used, and sometimes we have to make sure that we're careful. Take a look here. Let's suppose that Jeff attempted to compute the following integral, but was told by his teacher that his answer is wrong. What is wrong with Jeff's calculation? Can you spot anything that's wrong? Let me try to work through it, right? Let's see. Maybe he did the antiderivative wrong, right? He said that the antiderivative was negative 1 over x, or negative x to the negative first power, right? So, I mean, does that work? If I take the derivative of this, am I going to get back to 1 over x squared? I mean, I guess I could see. If I took the derivative, that negative 1 would come down and be back to a positive, and I'd lower the x to a negative 2. So that's going to be 1 over an x squared. All right, well, I guess that works out beautifully. The antiderivative here doesn't seem to be the problem. Okay, well, let's see. He plugged in then the value of 3. That seems okay. He plugged in the value of negative 1. So it should be negative a third minus the negative with the negative 1 plugged in. So that should be positive 1 on the inside. So negative a third minus 1 is negative 4. What's wrong? Well, hopefully you can see that the fundamental theorem of calculus part 2 has been incorrectly applied. And you might be thinking, wait, but how is it incorrectly applied? Like, he did the antiderivative perfectly, he plugged in all the values, he did the f of b minus the f of a. Everything's looking great. Well, the reason for this is that, notice that f of x equals 1 over x squared is discontinuous at x equals 0. And so f of x is not continuous on the interval from negative 1 to 3. If I was sketching a picture of what this function looks like, 1 over x squared is going to look something like this. I have a vertical asymptote sitting right here at the value of 0, so there's a big problem. I can't actually attempt to use fundamental theorem of calculus to answer this question. We can't use it. Now, sometimes this is going to happen to us. I mean, this is totally reasonable integral to pose, to ask. But I have to be aware that I can't just use fundamental theorem of calculus part 2 whenever I want. That's not the way that it worked. It required that we had a continuous function. And so the moment that I don't have a continuous function, I have no guarantee if that answer is going to be right or wrong. Chances are it's probably wrong. Now, in Calculus 2, we'll actually learn how to deal with integrals where the function is not continuous on the given interval. But for Calculus 1, the only thing that we would ever have to state is since the function is not continuous, since f of x is not continuous on negative 1 to 3, we cannot proceed. That's it. If you ever came across a discontinuous function, all you would ever have to write is just, hey, it's not continuous. I can't do anything. I can't use fundamental theorem of calculus. I can't go on. You could try a couple other things in terms of like maybe you could turn this into a big scary limit. But notice that's not going to be easy because I don't have a polynomial here. So ultimately, we're going to get down to this part where we're stuck. We can't go on. In Calculus 2, again, you'll talk about ways that you might be able to push past this point and still figure out how much area there is under the curve here from, say, negative 1 over to 3. And you'll be able to try and determine that. But for the moment, we don't know how we can possibly deal with that question. And so we're just left saying, I don't know. And in this sense, that's totally okay because you've recognized that you can't just go ahead and use fundamental theorem of calculus part 2 whenever you want. So this is a really important takeaway. Make sure that every time you're working through a question, you are always checking this. In our class this semester, you will always be required to write down, to verify that you have checked that your function is continuous. I will not be checking that for you. It is your job, again, to convince me that this condition is met. And so you definitely need to record that anytime you're interested in actually using the fundamental theorem part 2.